Welcome to the Future of Structures podcast, where we talk to the experts who are evolving our buildings for tomorrow. And here is your host, Adam Jones.
I just had an interview with Hamish Watson, who is the CEO of Polysolar. Polysolar are doing some really exciting space in the renewables sector. So they're most known for at the moment with their clear glazing solar windows. So they're already impressive as the first generation technology, but what's coming in the second generation technology could potentially disrupt a lot of the buildings industry with clear glazing. So as clear as your classic office building or your high-rise building with a thermal efficiency of U values of less than 1. So this could potentially be our facades in the future, where we create our buildings that are high-rise can potentially create renewable energy by themselves and aren't reliant on the grid. So if you're going to have net positive emission medium to high-rise buildings, then it looks like Polysolar might have the answers in the future. So they're also doing a lot of work in the battery space as well, which obviously goes hand in hand with solar. So Hamish is very, very smart, and I learnt a lot. Previous to this conversation, I knew very little about Polysolar and clear glazing solar panels, but what they're doing is potentially could solve a lot of the problems with our reliance on dirty energy. So I hope you guys enjoy it as much as I did. It was phenomenal from my perspective, one of my favourite interviews easily. And without any further ado, here is Hamish Watson.
My background's actually in strategy consultancy. So I worked initially in London, and then set up a consultancy, market research company in Asia, in Hong Kong initially, and then in China, and China, which was the first foreign registered market research company in China. Yep. Had offices in Beijing, Guangzhou, and Chengdu, Shanghai, and that was in the days when people went around in Mao suits and bicycles.
Yeah.
So my first client was a biscuit company, which was the first packet of biscuits in China.
Yeah.
To give you a feel for it. Anyway, so then moved back to the UK, the point of handover Hong Kong. Had a business initially in mobile data applications. So this was mobile technology, which was a pre-3G, which was a packet switch technology for allowing the insurance industry to give real-time quotations.
Yep.
Had other businesses and activities in between, and then was working as a consultant, advising Chinese companies on technology transfer and globalization.
Yeah. So
and had a Chinese client who was interested in getting into the solar industry. I had previously done work in the glass industry and other sectors, including having worked with a company doing plastic electronics. So this was the development of plastic light emitting diodes. The reverse of a plastic light emitting diode is an absorbing diode, which is a photovoltaic. And so proposed with this Chinese company that we develop a new technology in photovoltaics. They started building the factory while we were still in the lab. So we decided that actually they weren't suitable partners. And so dropped them and progressed it on my own. So that's the history of the company.
Yeah, nice. So were you doing the developing the technology by yourself, or was it by a bunch of guys at university and with PhDs and all of that as well?
So the technology of plastic electronics comes out of the Cavendish laboratories in Cambridge. And there were some spin-out companies of that, from that, one being a company like Cambridge Display Technologies, and the basic technology of a polymer organic photovoltaic is out of patent and all that sort of stuff. The sort of fundamental technology is out there, and so we set up to develop that, and with a number of partners at different universities, both Cambridge, Imperial, Sheffield, lots of places. Basically, we've been developing over the years.
Yeah, awesome.
And that's been primarily done with academic partners and institutional partners, and then we also do that. Our primary partner on it now is Merck, the chemical company.
Yep.
German chemical group.
So if you're explaining the technology, and if you can, it'd be great to maybe explain, traditional solar that everyone. Pretend we're a 6-year-old pretend I'm a 6-year-old at school learning it for the first time.
Fine. So we work in actually a number of different technologies, so you have to be a bit wary about what you're referring to each time. Basically how photovoltaics work is that the sun emits photons, and you're converting those into electrons in a semiconductor, and that's what a photovoltaic is. Okay, and they all fundamentally work the same way, but different technologies have different ways of working, and different materials to convert sunlight to electricity. So the reason that we've been developing organic photovoltaics is twofold. One is that it lends itself to be transparent. So it's very thinly deposited, and the active material is semi-transparent. And that's an advantage of it. The second advantage of it is that it can be liquid printed, so you can print it on any surface. And that allows you to make cells much more cheaply, and also much more varied in terms of how you do it. So the print process.
That's pretty impressive. So when you say printing, can you just explain that a bit more? Because it's probably obvious from your point of view, but it's pretty amazing for the people who haven't heard of, I guess, technology and even transparent glass.
Okay, so the type of printing doesn't actually matter too much. So you can spray print, you can slot die print, you can print, in virtually any way you want to. But basically, all you're doing is putting down a material layer. With our existing technology, we don't print. So what the products we've got on the market at the moment are a plasma vapor deposition process. So that's a vacuum deposit process. But the advantage that liquid printing has is that you can do it in much more cheaply and much more as a continuous process line.
So before we get into the transparent kind of solar with printing, what are some uses of that I guess that haven't been able to be used in the past?
So with the ability to print means you can do reel-to-reel type processes. You can print onto a plastic sort of PVB type layer that you would then put between glass. We actually don't do that. We print directly onto the glass. And the advantage of being able to print directly on the glass is that we can then make different unit sizes, and we also put on a sort of nano wire type system on there, so say visible wires, which can then draw out electricity from large pieces of glass without being visible.
Yeah, phenomenal. So with the transparency, is it at the moment when we say transparency, can you see can you see through it yet, or is it developing?
So yeah,
in
our current product. So the issue here is differentiating between our current market products and our next generation products, which we're starting to put into the market but aren't into full manufacture yet. So the liquid printing of organic photovoltaics is our next generation of products. Our existing products, how we produce those is that they are vacuum deposited. So that's a plasma chamber deposition. So that's how you make things like old CDs and that sort of thing.
Yeah.
In basic principle technologies.
Yeah.
And the disadvantage of that is that because it's done in a particular chamber, you can only put in a certain size of glass in there to deposit on, and that therefore restricts how big a piece of glass you can make.
Yeah. Wow. So I guess looking at it, say
and how that's produced then is that we then use a laser to pattern it, which means you're making holes in the active material there in order to let light through.
Yeah.
So that lets light through a very fine pattern system. So it looks like a tinted glass, but only if you look up close to it, you see the pattern.
Yeah.
With the next generation of organic photovoltaics, the actual active material is transparent, so you get no patterning whatsoever. It just looks like a conventional piece of glass.
That's absolutely crazy and exciting. So I guess when I think of that, my brain goes to, I guess, a building. So if you got, say, a developer or something is listening right now, is there any specific kind of projects that at this stage, as the technology is just, I guess, at its infancy, there is a good business case for it already? So if anyone's listening, they might, I guess, take it on.
Yeah. So the great advantage of photovoltaic glazing is that it is ultimately just glazing, and therefore you can replace any glass with glass that produces electricity. And we put it into everything from office building curtain walling through to domestic conservatories and skylines.
Yeah.
The opportunity really is as big as the glass market, if not bigger. So if you want the opaque version, you can put that on instead of a composite cladding or stone or metal or brick or whatever else you may build a building with.
Yeah.
And so you can cover an entire building with photovoltaic without it being noticeably a photovoltaic, and create zero carbon buildings as a result. So they are power plants in their own right, and never need to use fossil fuels. Yeah,
that's phenomenal. So what about, I guess, the high-rise buildings out there? Because in the past, I don't have a big renewable energy kind of background, but when I ask people, they always say there's not enough, I guess, roof area to be able to power, say, a high density building. So is this the solution to, I guess, potentially getting the more mid-rise and high-rise buildings to net positive emissions or zero emissions?
Yeah, so as the world moves into cities, those cities are increasingly high-rise, and the problem with a high-rise building is that the area of roof proportionate to the building is much, much smaller. And also the roof usually has other plant and equipment on it. So it's got all your cooling and venting and all that sort of stuff stuffed on the roof as well. And that means that putting conventional solar panels on the roof, while still sensible to do so, you have a very limited area that you can actually do it in. The great advantage of building integrated photovoltaics is that you are putting them on the side of the building or on other areas of the building which wouldn't normally have photovoltaics on them. Conventional photovoltaics are usually unsuitable for.
Yeah.
And that allows you to give a much bigger area and hence much more likely to meet the power requirements of that building itself. The other aspect of the technology and how it's important in modern architecture is that ideally in modern architecture, architects want to provide as much window as possible to allow natural light, etc. But the trouble with that is that windows let in a lot of heat and let out a lot of heat. And therefore, the more window space, the less thermally efficient the building becomes.
Yep.
With our technology, one of the advantages of the technology is it actually reduces the heat gain to the building quite significantly, and also reduces the heat losses, which means that you can have much bigger area of glass without the same thermal loss or gains or losses you might otherwise have. So you're reducing your air conditioning load significantly, and therefore reducing the power requirements of the building. Yeah,
wow. So it's got a greater, I guess, thermal conductivity or values than traditional glazing. Is that what you're saying? I know it a little bit, but
yeah. So our glass on a thermal insulation side is the equivalent of about a triple glazed unit.
Oh wow! Unit. What U value would that be for? I guess the mechanical architecture.
The U value usually below 1.
Oh wow! Yeah.
And then the thermal gain side is based on what's known as G values, and that's below 0.2. So again, it's like a very high efficient thermal glass.
Yeah, that's awesome. So how much electricity can it generate? Is it comparable to solar at the moment? And if you had a floor that was using, say, a high-rise building that eventually maybe had a lot of this clear glazing solar, could it generate enough electricity for a building?
Yeah, so our current products are less efficient than they have the potential to become. So the technology has the potential to improve its efficiency quite significantly. But with our existing products, their efficiency at converting sunlight to energy relative to conventional crystalline panels is about half as efficient. But the big difference is, which is why we still recommend that you put conventional crystalline silicon on the roof of the office building before you do the cladding on the side. But the big difference really is that crystalline silicon is not really very suitable for building integrated applications for three basic reasons. One is that the crystalline silicon really requires direct sunlight, so it doesn't work very well in low light levels. Its efficiency drops off quite dramatically. And therefore, if you're putting it in the vertical or anywhere which has low light, generally, i.e. the east and the west and the north side of the building, for example, it really just won't work, and therefore you wouldn't use it in those circumstances. The second reason is that photovoltaics are less efficient the higher the temperature. So with every degree increase in temperature, their efficiency drops off quite significantly. And that's fine on a rooftop or an open field where you've got them ventilated, but as soon as you put them into a building where you haven't got them ventilated, it means that the crystalline silicon really is not suitable for those environments. You can't insulate directly against them, for example. With thin film, it is less affected by temperature, and therefore you can happily put them into double glazing units without any thermal differential. You can put them in directly insulate against them, etc. And then the third element really is their susceptibility to shading. So one of the big problems with photovoltaics in general is that if it's shaded, it's not working. But not only is the single panel not working, it's the whole array, the whole string is not working. So with conventional crystalline silicon cells, you link in long series strings in order to get the voltage up.
Yep.
And if you shade one or cover one, it will always work at the lowest denominator, and therefore that's quite difficult in a building where you very seldomly have consistent light. coverage,
Yeah.
and no shading. With thin film technology, our technology, you link in parallel much higher voltage units, which you link in parallel, and therefore the shading is only proportionate to the area that's covered. You're not losing out the whole array.
Yeah, cool. And I guess we'll definitely get back to the solar panels, but looking again at the city as a whole, if we had buildings that were generating electricity and maybe eventually taking energy back to the grid, what do you think for energy storage looks like in a building, and best combining with your Polysolar technology if they wanted to store energy and really ramp up the renewable energy a building can generate?
Yeah, so the reduction in the cost of batteries is making storage of renewable a much more viable proposition. Currently, basically, how a PV system works is that you generate power from your building. You will use that power as far as possible on the site itself, and then any excess usually gets put into the grid for other people to use. The problem with that arrangement is that you don't get paid very much by the grid for that excess power that you're giving them. With battery storage, it allows you to produce the power and store it for when you need it. So you're not, in a sense, wasting that energy by giving it back to the grid. It's not actually wasted. It's somebody using the energy. It's just it's not you making the money out of it.
Yeah.
Now, with the storage, you're storing that power in your batteries for when you want to use it. The problem really is balancing that to optimize both the capital investment in the batteries and also the environmental impact of creating those batteries in the first place against how much power you actually need at peak time. So you don't necessarily want to be divorced from the grid. You want to be able to get power from the grid when you need it. But equally, you don't want such a huge battery bank to ensure that every time you've always got enough power. And that's the trade-off you've really got with battery storage, is optimizing that side of it. The other sort of area of interest more generally is that the grid itself is increasingly interested in using the battery storage element as a support for the grid. So one of the problems with renewables more generally, so that's sort of solar farms and wind farms and the like, is that they produce power when it's windy or sunny, and nothing when it's not. And in order for everybody to be able to turn on their lights, etc., the national grid needs to be producing power for those occasions, which means that it's got a lot of standby power plants sitting there waiting to be used when there's no wind and no sun. Now, if they can use people's batteries to compensate for that additional requirement, that means that they're not having to waste investment in gas-fired power stations, which are sitting there idle most of the time. And what we're doing as a company is working on the battery side also, looking at car batteries included in that, as being something that the grid can then tap into. So not only is the grid charging those batteries, it is also discharging those batteries, and those batteries are discharging to the grid as required. That's where things will head, and the advantage of that is that you get a significant premium for the price of that electricity that you're either delivering to the grid or the grid's offloading to you when it's getting too much. And therefore the economics of it are quite interesting in their own right.
One thing that doesn't really get talked to,
and that will be done as a building by building basis at the end of the day. That the technology is being developed at the moment to be able to do that on a micro level of trading. Yeah,
awesome. I guess I've got a few questions from that. But one thing I've noticed that doesn't really get talked about is if batteries and solar are going to be a large scale problem for energy around the world, is what about the raw materials? Do we have enough raw materials to, I guess, produce the solar panels and to produce the batteries that might be required to power whole grids of cities?
Yeah, so in solar panels, the fundamental materials of most solar panels, I'm not saying universally, are readily available. Silicon is sand, glass is sand, there's a lot of that around. There are some more rarer type materials that are used in certain elements of that that may be slightly more restricted. Equally with batteries have the same issue, is that there are things like lithium is a finite material, but there's a fair amount of it around. Like with most materials, if there's a shortage, people create the innovation to allow them to create more of it or recycle it or whatever else might be required to access it. So in the shorter term, I don't think there's a huge concern that the raw materials are too limited. I think it's more to do with those materials being in places or currently being mined in places which may not be ideal from a strategic and security point of view.
So is the rate that solar is developing and batteries developing, and I guess the dirty energy, I guess, is just stagnating and going down. So do you think we're at the point now where it's the obvious option already to go with clean energy, or when do you think it'll just become that obvious that all new developments are choosing to go with a high amount of renewable energy? So in what time frame do you see big changes happening?
Well, in the UK, we're already hitting with solar and wind to a degree a cost-neutral technology, i.e. it's no more expensive than the traditional technologies to deploy. So we're already there to a large degree. It's not, it's still on the cusp, but it is there. So renewables make economic sense already. They make obviously environmental sense, and therefore I can't see that there is much opportunity for traditional power generation beyond being a backup support system. Having said that, Australia's just decided to go back to coal for power generation.
Yeah, there's a bit of resistance there.
So the political environment is different. But if you look at the basic fundamentals of the technologies and what makes logical sense, not necessarily political sense, but logical sense, renewables are there already, and it makes sense to deploy them as far as possible. And that's all sort of forms of it, but it's also putting them on buildings, not just on solar farms where we're using land that might otherwise be productive for feeding us.
As we wrap it up now, I definitely didn't want to go down the political path, but I'd just love to get just one quick opinion. So being in the cusp of, I guess, clean energy, do you get much resistance from the old industries who, I guess, had the monopoly on the energy market, and I guess all the new technologies like polysolar and batteries are coming through and are disrupting the old things? Is there much resistance from the politics or old business, or is a lot of people accepting these new changes coming through?
Interestingly, I think the oil companies have accepted that their days are numbered, or certainly their business models, traditional business models, are numbered. So all the big majors are looking at alternatives to how that they will move forward in the future. And that goes everybody from sort of Saudi Arabia through to BP. So I think that there is the exceptions that renewables will be a significant part of our energy mix in the future, and the traditional carbon-emitting technologies will not be. I don't think that there's a direct resistance in those companies per se. I think they have yet to understand themselves how they can operate in that environment. So with individuals generating their own power, what does that mean to an EON or equivalent power delivery company? It changes the whole nature of their power structure and how they operate, and getting that business models in place is yet to be realised, I think.
Yeah, fantastic. So as a wrap it up now, so what do you think will have the biggest impact in the buildings industry going forward? And I guess you might be a bit biased, but maybe anything that we have or haven't covered.
Yeah, I mean, I think in terms of the building industry, it is a conservative sector. There's a reasonably slow moving in terms of adopting new technologies. Yeah. But equally, buildings represent sort of nearly half our emissions in terms of CO2, and therefore are a key area that needs to be addressed. That is usually driven by building regulations, and those building regulations do rather jump around, but the general direction is very clear that zero carbon buildings are coming in at a very rapid rate, and that renewable energy therefore is an essential element of that. It is also a cost-effective element of that, and therefore it will be adopted. So I don't have any question that it will be adopted. It's just how quickly it's adopted.
Hey guys, Adam here. Just before you go, just one quick request. If you're enjoying the show, please leave a review. It helps our rating and ranking on iTunes, so more people can hear from the people who are making our cities better places for our future.